if you buy something, does tax get added or does tax get subtracted?
Added.
Gets added. So if you look at the cost plus the tax, you get your total that you pay. So in terms of a multiplication or an addition problem, does that make sense? Cost of the item plus the tax gives you the total cost.
Yeah.
And the tax, what did they say it was, 7.5%?
Well,
it said that there was 7.5% taken away, I thought.
no, because it's sales tax.
Sales tax.
Sales tax is always added. Now, they might have given you the price of the item after the tax is added, right?
Yeah.
Yes.
Okay, so they did. So what they gave you is they gave you this number. And that was $8.60?
Yes.
I'm gonna leave the dollar symbols out of here until we get to the very end, okay? We'll just make sure everything is in dollars and have the decimal points where they belong. So, if it was $8.60, do they tell us the cost of the item?
No.
No,
They do
they
not.
don't. Do they tell us how much tax there was?
Yes.
Do they tell you in dollars and cents?
No.
Yeah.
No, they tell you as a percent, don't they?
Mhm.
And that percent is
7.5.
7.5%. But 7.5% of what?
Of the total.
So these are challenging problems.
Wait, no,
just so you
it's
know.
the cost,
would be
it's the
like
cost plus the
90,
tax. So it's 100,
2.5%.
so you have 100 and then you add the
Oh, wait,
7.5.
let's go one at a time. What did you say?
So the cost is 100%, but plus the tax is adding 7.5% to it, to the total,
Oh,
the cost, so that's.
okay, so that's one way of looking at it.
0.75.
I think TJ, what you're saying is that you pay 100%
For the cost.
of the, call the cost C.
Mhm.
And you add 7.5% of the cost C. We don't know what the cost is though, do we? And then you said that this is 107%, 107.5% of the, I'm gonna write the word now, cost. Is that right? That's what you're saying.
Huh.
Wait.
What are you saying?
I did like, I found it as a decimal, I did like 0.925 of, that cost, and then I multiplied it and,
So you did 0.925 of this?
no, B, or C,
So this is 92.5% written, this is 92.5% written as a decimal. I'm just gonna put that here. That's what that is. And then what did you do with that number?
I multiplied it by C, and that's equal to total cost.
That total? Okay, so,
Because
yeah,
it's
we're,
92.5%, which is plus 97.5 is equal to.
so she's saying that 92% of the or 92.5% of the original cost is equal to the total cost. You're shaking your head. I mean, the 92.5%, I can see that. That comes from the 7.5 taken off of the 100. So if you did something here, if you multiplied a number less than 1 by something and you got 8.6, does this number have to be bigger than 8.6 or smaller? You're taking something less than 1 times this and getting that. So this better be bigger, so the number's getting smaller, so that original cost would be more than 860. So in other words, your original cost before you add tax would be less than, or would be more than 860.
So that's
No,
not
it doesn't
correct.
make sense because you're adding tax.
Yeah.
You're adding on to this, you're not multiplying it, you're adding it.
Yeah, here, let's just do this. Call that C. Divide by 0.925. This number's gonna be bigger than 860 when you're done. So there's some good thinking here. We can think about this 92.5%, yes. But this doesn't get us where we wanna be. So I'm just gonna do that. Let's go back up to this. So if you change that number to a decimal so that you could multiply by C and get 860, what would this number become?
1.075.
Okay, so now to solve this, how do you solve it?
You good?
Anybody?
Oh, sorry.
You hear? Is this stuff starting to get all fuzzy and blurry and blow by you like a big old dust storm? Yeah, it does. This is not easy.
You'd put,
This is one of the great struggles of 8th grade, believe me. Don't feel bad, but don't give up either. Try your best with it.
1.75. Well, yeah.
We want to divide by 1.075. Who's got the calculator? Go.
8.
First of all, is that number going to be bigger than 8.6 or smaller?
Smaller.
That'll be smaller.
It's 8.
It's 8, huh? Okay, so then if I'd write under here, C is equal to $8. So you take $8, you add a tax of 7.5%, and it gets up to 860. Does it make sense if somebody said that to you? $8 plus the tax, the total's gonna be 860?
Yeah.
It's a higher tax than we're used to, but it's not unusual. Seattle's that high. So, a lot of the big cities are that high. Now, we'll break it down into pieces, okay? First off, you have the cost of the item, and you don't know what it is. So I might think of it like this. Some of you like to see it real sequential, stepwise. So if I say the cost plus the tax equals, the cost is a variable because I don't know what it is. The tax is 7.5% of the cost, and that is going to be equal to 860. So then if you just say the cost plus 0.075 times C, is 8. I'm going to leave out the dollar symbol. Then you can piece this together. 1 times the cost plus 7.5% of the cost. That's where you get down to this 1.075 that TJ was talking about. 1.075C. And then you do your division and you come out and you have $8. Yeah. Talk to me. What's your question?
Wait, could you do that next step, like, because you did the, after the first step, do that one again? Yeah.
Explain this one?
Yeah, again.
Yeah, so when I wrote it the first time through, I did not have the 1C, I just had C.
Yeah.
Because I said the cost, which I don't know, call it a variable, plus the tax, which is 7.5% of the cost that I don't know, adds up to 860. So then I think to myself, well, C is the same as 1C, and that's something that some of us are more comfortable with than others, and that's okay. But 1 times C is equal to C. So when we write a variable, like on the quiz that we had the other day, where you had 2A plus A, I think that's what it was. Well, that's 3A. So this is 1C plus a small part of C, which when you add those together, that's 1.075C. I'm sorry?
And then do you divide that, like, on both sides?
Yes, then this is being multiplied by C, so to undo the multiplication, we divide. But in order to have both sides still equal, we have to do the same thing to both sides.
Okay.
You think about half of you, half of you. You know, if I double half of you and we're gonna keep the sides equal, you better double this over here. It's like choosing sides to play basketball or kickball or something, right? And if that side gets 2 more people, you guys better get 2 more people, right? And if we cut your team in half, we have to cut his team in half, otherwise we don't think of them as being equal. So yeah, even in PE there's math. Just don't ever let Mr. Brittenhead tell you that when you drop something like this, it gets halfway to the floor, right? When you let go of it, and then it gets halfway to the floor again. And then if it always only gets halfway to the floor, how does it ever get to the floor? He likes that one. It got to the floor, right?
It didn't stop halfway.
It didn't stop halfway. Boy, he'll throw that one at you before time is up. And when he does, I'll explain to you why it doesn't work that way. So, that's 9, right? They're kind of complicated sometimes. A lot of you had $8, but how you got it was a little different. It's another way to do it, I think. And I want to ask you if it's going to work for work or not when we get through with it. I'll explain. Somebody might be thinking, well, if there's in this price is 7.5% tax, then 92.5%, which is 0.925, of that 860 is the original cost. Can we do that? Tell me, Rylan, can you do it? Does that come out the same or not? You got your calculator. I thought you were punching it out. 0.925 times 860. No, it doesn't, does it? It's off by a little bit. How much do you get?
7.955.
And then there's a 5. So 795 or 796, but that's not $8, is it? And here's why. Some people think, well, we can just take away 7.5% from that. But that would would not work, because if you take the cost, here's C, and then we take a little sliver of that cost. This is 7.5% of C, so it's a little bit more. And all of this ends up adding up to $8.60. If I were to just say I wanted to take 92.5% of that total price, I'd get 92.5% of this number, and then I'd also get 92.5% of that number. You don't get you're gonna, 92.5% of this doesn't fit what's missing from this part. So 92.5% of a bigger number, that bigger number came from adding 100% and 7.5%. So in other words, this value is 107.5%. If you subtract 92.5%, that doesn't get you to the 100. It doesn't work that way. So you have to add them together. You can't start with this and work backwards. And I don't know if I saw this with any of your work. I saw a lot of $8 when I walked around, and I saw a lot of different ways for you to get $8. What was another problem I gave to you? 14, was that one tough? And 10 was tough? Okay, I heard 10 though, yes. After a reduction of 30%, the sale of a ski jacket was $67.20. That one, there's lots of ways to solve. Please be another one. Gotta be another one. Those things, the foam is starting to fall apart, and every time I touch it, it's got dust on it. Okay. So there's lots of ways to do this one. What's the price after it had the 67? 20? So that's the price after we subtracted 30%. So the original price, and then we subtract 30% of the original price. But you don't know what the original price was. So if you started like this right here, how do you write 30% as a decimal? And then what is 1p subtract 0.3p? How much? 0.7. So in other words, you started with 100% of the price. And then they had 30% taken away. So that's what was removed from the total price. So now this here is 70% of the price, or 0.7 times P. So you could have started with something sort of like this, or you could have just in your head said, well, 30% off is 70% of. So I gotta pay for 70% of it, and then just write it from here, and then do your division. So what do you get? What kind of answer did you have? How much? 96 even?
Yeah.
Okay, so then if you took $96, 70% of that is $67.20. Or if you subtracted 30%, you'd be subtracting $18.80. Is that right? Or is it $28.80? $28.80. So if you did this one up here, if you, like, some people might say, well, we took 30% of a number, and then you start doing trial and error and subtracting and see if you get close. This one could work because it's a nice even number, but I would rather you don't do trial and error. Try to write it out that way. Okay, so then you said 14. 3/7 is equal to 2/9 x.
Don't delete the 5. No. I mean erase. Sorry.
What did you say? You didn't want me to erase?
I said delete it the first time, but I meant
Oh,
erase.
no, I won't. No, I won't erase stuff that fast. And it's recorded too, so you can just go on the YouTube if you ever have to. Just pause it and look at it, write it down. Yes.
So for 14, is it okay that I rearranged it?
How did you rearrange it?
I put 2/9 times x equals 3/7.
Oh, so you did this.
It's still the same problem.
Yeah, easier to look at for you? Yeah, if it's easier to look at, sure, you can switch it. You bet. As long as you keep that separate from that. Yeah, not a problem. A lot of people do that. Because, or you can rearrange the multiplication even, change the order, but some people will do that because it just looks better for them. I was that way when I learned this stuff. this is multiplication, and to undo multiplication is to divide. But we don't do division with fractions the same way we do with integers. How do we do division of fractions? Multiplied by the reciprocal. So what is the reciprocal of 2/9? 9 over 2. So whatever I do on that side, I think of having to do on this side. 9 over 2. So 2 over 2 is going to cancel, 9 over 9 is going to cancel. You're left with x. So what does this change, or what does this turn into? 27/14. Can you simplify it?
No.
No, you can see here you cannot simplify it. Prime, prime, prime. 7 doesn't go into 9.
Should we turn it into a mixed number?
No, I wouldn't. I'd leave it just like that. I wouldn't take the time to put it into a mixed number because you're starting with fractions and with fractions. If there's mixed numbers in what you start with, then maybe you want to work yourself back to mixed numbers. If they're decimal numbers, stay with decimal numbers. Don't change it to a decimal though. No, no, no. To check this one, to make sure you did it correctly, it's 2/9 times x, and that's x. So you have 2/9 times 27/14, and you want to ask, does that equal 3/7? And without having to do all the multiplication, and then simplifying, see if you can simplify before you multiply. Do you see anything in there that we can simplify first?
Yes.
Don't yawn loud like that. 9 and 27, how does that get simplified? 3 and 1. 2 and 14? 1 and 7. There it is, there's 3/7. So that works. 1 times 3, 1 times 7. Yeah, don't go change it into 54/126. If you multiply that all out, then you've got this, 54 over, I believe, 126. And that's going to take time to simplify back down. So simplify when the numbers are small, that you can do them in your head. The whole idea is to become more efficient. And the calculator gets used for bigger stuff, not little stuff. Calculator's a great tool, but it shouldn't be a continuous crutch. Because in the end, that will slow us down. Any more that we should talk about, or should we just move on and do something else?
15 and 16.
Okay. 15, 3b, I'll do one or the other. Which one do you want me to do? Okay, 3b plus 2b. No, let's do 16, because the answer's not in the back for 16, but it is for 15 if you need to check your work. Let's do 16. 9t minus 3t plus 2t. 9t minus 3t.
Plus 2t equals 2.4.
Thank you. Okay. So with something like this, we need to know what t is. So what do you think is a good first step?
Order of operations.
Yes.
Sorry.
What are the order of operations? What do you mean by that? Yes?
Addition first, then subtraction. Left.
Oh, so you're saying you want to combine all of this, is that right?
Correct.
Okay, so we call that combined like terms. So there's 9t, you do subtract 3 first. So what's 9 subtract 3?
6.
Plus 2? 8t. Now can you do this?
Yes.
What would we do next step? Divide by 8 on both sides. And then here, this is where so many people just grab a calculator, 2.4 divided by 8. But we can do this easier. If you multiply the top number by 10 and the bottom number by 10, now you have 24 over 80. And then you can simplify that. Okay, the first thing I did is I multiplied the top by 10 and the bottom by 10 to get rid of the decimal point. Then they're both even. So in my head, I would divide both of these by 2 until they weren't even, or else I was done. And so 12 over 40, 6 over 20, 3 over 10. 3/10.
Couldn't we do it as a decimal?
Sure. You could. You could also grab a calculator, but that would be kind of cheating your brain out of being able to do something. Don't cheat your brain out of doing something. Keep your brain active.
Well, when I looked at it, I just saw 24 and 8, and then
Yeah, some people think, oh, well, that's like
Okay.
24 divided by 8, but move the decimal point one place.
yeah.
That's a good way to think of it.
That was, I did that too, and then.
If it
I did
was
back to the
24
right
divided by
column.
8, it would be 3, but it's a factor of 10 less, so your answer is a factor of 10 less. That's good thinking, that's number sense. If it was 24 divided by 8, you would get 3,
And you got to
but we had to move the decimal back, so we gotta move the decimal back in our answer. Compared to how you're thinking about it, okay? So you can do number 15. Combine like terms, remove parentheses, you gotta do all that stuff. The idea is we're gonna get it boiled down to looking something like that. A number times the variable is equal to some value. You get more practice, because we're gonna add to this, but not today. Today, we're gonna take a look at stuff with our graphing calculator. Teach you a little bit of how to do some tracing and things like that, and come up with values off of a graph when you know the equation. Ooh. Yeah. You have your calculators?
Yeah.
All right. So they give this skill to us, or give us practice with this skill of using the calculator's graph to find answers by talking about how fast tortoises move. So this is 8-7. Yes.
I'm not feeling very
You should run to the office then, or walk.
Wait, what?
Okay. Who did you eat lunch with this morning?
good. Me?
Yeah.
Okay.
Can you put your books up, please?
Like my locker? Or on the box?
In the box, if you got a box. Thanks. So who had breakfast next to him? You? Who else? You were at the same, who else was at the same table?
Only 2 people table.
Really? Okay. You guys sit in the same places?
Basically.
Okay, good. All right. No problem. All right, so graphing y equals ax plus b. For example, 2x plus 7. So the a and the b are numbers. When we write an equation, the y and the x stay y and x. So the idea is that we have 2 variables. So with that, one way to think about this is if x has some value, we can figure out what the y value is that goes with it. So we're not solving just for one number when we see an equation like this. So for example, don't write this here, but when we had 4x is equal to 12 or something like that, there's one solution. Because there's only one variable. If I wrote this as 4x equals y, well, when x is a number, y is a different number, isn't it? this is 2, y is 8. If this is 1, y is 4. So when we look at something like this equation here, it's no different. We're just adding 7. So if x is equal to 0, 7 has to be, or I'm sorry, y has to be equal to 7. If x is equal to 1, what's the y value going to be? 1 times 2 plus 7. 1 times 2 plus 7, 9. If x is equal to negative 2, take your time. I'm sorry, negative 1. Negative 1 times 2 is? Negative 2 plus 7 is 5. And if x was equal to 2, 2 times 2, 11. You see how these are always changing by 2? As long as x changes by 1. That's what that number tells us. You notice that when x is 0, that's what that number tells us. So put this into your graphing calculator. So do you remember where that all goes? All right, so you're turned on, go to the upper left-hand corner, way up top, the little thing that says y equals. If you have an equation in there, remove it. So we're going to go to y equals. If you have any equations in here, clear them. And then the x is found next to the alpha, the green alpha key, where it says xt, and then there's that weird shape that's called theta. Yeah, so what you're going to type, you have the y in there already, so all you have to type is 2, the x, plus 7. Help each other if you need. Are you in? You guys have 2x plus 7? Okay, so then a quick way to graph something just in a standard window, in a window that goes from negative 10 to 10 vertically and horizontally. A real quick way to do this is to go to zoom. So up on the top row in the center, there's zoom. And you look down there, you see where it says Z standard, number 6. You can either scroll down or you can just type the number 6. And it graphs it. It should. Yeah, so you hit zoom. So when you're at zoom, you hit number 6.
How do you hit something?
Well, you can go down with arrows and then hit enter, or you can just type the number that's in front of the word. Yep. Yeah, I think you have this stat plot still turned on. Okay, so that's a stat plot, and you've got that on. So,
And this is his favorite song.
are we all good over here? Your calculator. Yeah, we said this before, you gotta bring it, right? It's hard to not have it and follow what we're doing when the lesson is based on it. It's gotta be with us every single day. It's like a hammer for a carpenter. All right, now, when you're working with these, if you haven't, like these guys back here, it wouldn't graph, it said error. And oftentimes what that is it's trying to get information from your lists, L1 and L2, and it doesn't want to fit onto the graph. So sometimes it'll give you an error message. And all you have to do is go to the second, and then straight above that stat plot, and turn off. Some of you have that graphing turned on, and you're still getting it on your screen. So some of you on your screen, you've got the line of the equation, but then you have a whole bunch of points that are put on there as well. I have that because I still have my stat plot on for list 1 and list 2. So go second key, the blue one, and right above it, stat plot, and then you'll see which ones are turned on. And use your arrows and enter key to turn it off, and then go back to your graph, and the graph should be clean. Okay, so here's what I'd like to do with this now. We're going to add another line to this. Now, this is a real simple, straightforward function or equation, and so we're using something that's easy to work with before we do harder things. Let's say I wanted to know what the solution was when y is equal to -2, for example. So when y is equal to -2, first of all, a picture of this. You've got a graph that goes up like this. And then here's your x and here's your y-axis. And every single one of these points on this line comes from a table like this. And it fits this rule. Yes?
It has a lot of other decimals with -2. Am I?
Where are you at? Are you on the graph? Oh, you're tracing. Don't worry about that. We're not going to trace right now, okay? All right. So if we were to go down the y-axis, this is where -2 is. And if you were to go straight across, this point here corresponds to -2 for y, and it goes along with some value of x right here. Now, if we can figure out what it is, it's not that hard. But from the graph, where -2 and that value of x are, that's a solution because it's a point on the line. So here's what we want to do. We want to add another line to your graph. So you're going to go back to y equals up the upper left-hand corner. And I want you to graph this. So just in the y equals, for the second function, move down. Make sure you use the negative symbol, which is in parentheses, 2. And then just hit graph again. So now you're going to have 2 lines.
Wait, do we put y equals 2?
Yeah.
Or y equals
They're
-2?
parallel.
They're parallel?
Yeah.
I don't think so.
No, I'm saying to the y-axis.
Oh, yeah, it's a horizontal line, isn't it?
Yeah.
Yeah, because when you put in y equals -2, that means that every single point has -2 for the y coordinate, regardless of what x is. X can be anything. So this is an example of a horizontal line. So this horizontal line and then this line here, which is the function y equals 2x plus 7, has an intersection. It has a common point. It has a single coordinate pair where that ordered pair fits this rule and it fits this rule. So Clover, how did you get that dot on your graph?
I pressed
Trace, okay, the upper row on the top. Way over on the right, there's a trace function. Hit trace and you'll see a little cursor. I'm not sure which line it's on. Do you know which line it's on?
yeah, it's on your y equals x. 2x.
2x plus 7 is where it starts?
Yeah.
Okay, so you can use your arrows left and right to move up and down that line. And if you use the up and down arrow, you can jump back and forth between the 2 graph lines. Yeah.
I did that
I'm gonna hit this again.
All right. So when you're using the trace function, you can slide and you can get really close to figure out approximately what the solution is. But there's a way to actually make the calculator tell you the exact point. You see, if you look on the bottom of your screen when you're sliding back and forth, probably, good job. Yeah. So when you're sliding along with the trace, on the bottom of the screen, it gives you the ordered pair of what your location is. But it's never nice numbers, is it?
No,
It can be like
unless,
negative 2.05.
unless you're on the actual.
Yeah, they're a mess. And we're hoping that that's like an integer location. What we're doing is we're hoping for that to be some easy pair of x and y coordinates. And there's a way to figure out how to do that. So you're all on the screen looking at the graph, right?
Correct.
Okay, so we can get the calculator to tell us exactly what it is. You have to be patient with me with this one. Because this one I don't have just stuck in my head where I can just rattle it off like the Star Spangled Banner or something like that. Okay, so while you're in the trace function, you need to go to stat, S-T-A-T, right in the middle top, hit it once. It will read edit calc and tests. Stat, top center. That's stat plot, stat, S-T-A-T, it's a black key. And then use your arrows to move over to calc.
Calc.
No. No. Evil. Shoot, that's not it. Okay, so doesn't matter where you are. Hit the second key once, the blue one, and then hit that trace. Yeah, blue on the left.
Trace.
Yep, trace, which is on the top.
Calculate.
Ah, there we go. Now, that's what I want. So second, and then the trace. And then it's gonna say value, 0, minimum, maximum, yes?
Yes.
Scroll down to number 5 and hit enter. Now you're back on your screen, don't hit anything. And it will say to you, first curve, question mark.
Oh.
So when it says first curve, you use your arrows to slide your cursor along one of those two graphed lines. I'm not sure what it's gonna put you on first, it'll be different. But you use your arrow, or use your arrows to get your cursor as close to that intersection as you can. And then you hit enter once.
Wait, which, oh, to where they.
Yeah, so you move the
Second
cursor
curve.
really close to the intersection.
Yeah, second
And then
curve.
you hit enter one time. And then you look at the bottom and you make sure you have your cursor really, really close, because it will jump to the other line. And you hit enter again, and then when it says guess, you hit enter and it will give you the intersection.
Wait, what?
Wait, so do I hit enter when it says guess?
Okay, so let me do this in like little areas here. Okay, so you have it. Can you do it again?
Oh, yeah, I don't know.
Second, cal, intersect. Now you remember what you did there? First curve, get it close, and then hit enter. Yes. So help, try to help Clover if you can. Okay, so where are you at right now?
Second curve.
Okay, you have the cursor really close to it, so hit enter. Yes, hit enter. Bingo.
Negative 4.5.
Yeah, you just have to hit enter a couple of times. These are straight lines, so it's a pretty straightforward thing to do. There you go, you're on the table now.
What'd you get,
Come on, did you get it to happen? Okay, second,
That's what I got.
cal. Number 5 for intersect.
I got that lines.
The second cal. Oh, you have to, hold on. Yeah, second cal. Just hit the number 5.
Okay, so -2, and then we're.
Just got rid of No, that did not.
Maybe it's because you didn't sleep.
Ah, I am on the ground. Jeez, woman. It was all that was.
It was really. I just pressed it right. I just moved your
Your
finger
graph
right.
is, no, it's not, it's, you just scrolled over.
Yeah. See?
Oh, you don't have to. Kate, can you help her get the equations in from the get go from the beginning?
And then it was gone.
Work, you got it to happen? You got it to happen?
Whatever.
You got it to happen? Can you show her how to do it again?
Get out of here, Bishop.
You getting it to happen or not?
Well, when I pressed enter.
Put it in the order, put it on the bottom.
Dang it. I have to do this stupid thing all over.
I did it. I'm so good.
Hey, okay, that means woman stole my pencil.
Okay.
So that's your first of those steps. Now you're on the right one.
Hey, Clover.
Now you've got it.
No, never mind, help me.
And it says yes. You see that?
Bestie, I love you. Wanna help Bessie out? Can you get my pencil back from Lucia? No.
Okay, who is still not making it work?
It's all Lucia. But that's my only pencil, Lucia.
Negative 4.5?
God dang it. I have to.
Negative 2?
Oh, I got it. I moved this intersection.
Pencil.
So are you guys all making it work here? So then go back to Zoom, Z standard, number 6. And then, there it is. Now she can work with it.
Dad.
Out, out, out. Yeah, you can take this one down again. You take something of yours.
Don't worry, I will. All right.
It's just me and you need to come up against it.
Okay, so here's a couple things you guys can write down in your notebook.
And we can fight each other.
Okay.
Okay.
So with your TID4s, the more you do it, the more it will become second nature. But for now, these things that are new, we need to write them down so we can go back and do them again. In order to find the intersection of two lines, you have to have them graphed. And I might write this, I might write intersection of two lines. And that's what we were doing here, we were locating that ordered pair, which came out to be -4.5, -2. So in order to have the calculator do that for us, we had to hit the second key, and then we had to hit the trace, but that's calc when you have it on the second. And then what did you scroll down to which number?
Intersect.
Intersect. Which was like number 5. But you go down to intersect. And then what did you do after you got to intersect? I think you just had to hit enter.
Yeah, we had to go to the spot where you choose the intersection to two lines.
And then what that did is it took you to the graph. And it said first curve, and you had to hit enter, and it did second curve, and you had to hit enter, and then it said guess.
Yeah.
So I'm not gonna write all of that, but I'm gonna say that you had this choice. Now, when they say curve, that's kind of a generic way to say line, because not all lines are straight. Some of them are curved. So the first curve, and then you had to hit enter, second curve. So you're just choosing them, because you might have 3 or 4 lines on your graph, and you gotta make sure you choose the right lines. And then the guess, and hit enter, and then you got your intersection. Those are the steps to that. So now algebraically, let's go back and make sure the graphing calculator did the right thing. Give me a moment to write this down.
What's the TI for?
Texas Instruments. It's the name of the company. Okay, so this intersection right here, that's an X and a Y value. We should be able to say that it fits into this table. If it fits into this equation. So here's what we can do to check to make sure. The Y value is -2. So what I'm going to do is I'm going to write -2 equals 2 times the X value plus 7. So we just substitute that in and then do the arithmetic. Is it correct?
Why do we need the 4.5?
Sorry, say that, please?
Why do we need the 4.5, or is that just a number?
Well, that's not a number. That's what your calculator said the intersection of these two lines was. So your calculator said that this point here is that location.
Yeah, okay.
So we're just checking to make sure it's correct. Because that's the equation that we were identifying when y is equal to -2. There's some value of x that makes the equation true. So take these two take these two coordinates, substitute them in. This is the y value. -4.5 is the x value. And solve that. It's 2 times -4.5. That's -9. What's -9 plus 7? -2. Does it work? All right, sweet. Okay, so here's what your job is for the next couple of days. Try the first 3 problems on page 528. You will need your calculator. First 3 problems on page 528. And then bring it back and we'll,
Page 528, 1 through 3.
yep, page 528, 1 through 3. When you come back
528.
Friday, we'll see what that all looks like. Page 528, 1 through 3.
Never know Carl did that.
Sorry, Archie had a dentist appointment.
That's all right. Nothing's running away.
Thank you.
You're
I
welcome.
filled out my forms, but I totally forgot to. Really, what it is I don't know the schedule. That's what. I don't realize that. I never remember that second is first on Wednesday.
Yeah, it's weird. Oh, I'm sorry. Thank you. Have a nice day. TJ,